In this video, we're going to look at other ways to classify data, namely the 4 levels of measurement. We have nominal, ordinal, interval, and ratio. Let's go through each of them. Nominal data are qualitative in nature, meaning it's data that consists of names, labels, and other such categorical items. But the most important thing about nominal data is that it cannot be arranged in any meaningful order. In this example, we're trying to see what people's favorite colored M&M is. Since the dataset consists of colors, we cannot order them in any meaningful way. Meaning, we can't really say that red is greater than orange or brown is less than yellow. It doesn't really make any sense. So therefore, we consider this nominal data. A news program conducts an exit poll, in which voters were asked to identify their political party. The answers that people give are considered nominal because they're just the names of political parties, and we can't really list names in a meaningful order. For example, if Democrats come first on the list, or second or last, it would make no difference. Ordinal data can be arranged in some order, but the differences between them cannot be determined or are meaningless. For example, at the end of the semester, you will receive some letter grade. You know that receiving an A is better than receiving a C. So there's definitely a hierarchy to the values of these letters. But what we don't know is how much better A is than C. Meaning, if I take A minus C, what does that equal? It really doesn't equal anything. Therefore, the dataset of letter grades is ordinal. What if we rank colleges from best to worst? Well, again, there's definitely a meaning to being the first on the list. It means that you're the best out of all the colleges. However, since they are just names, the differences don't make any sense. Meaning, if I were to take Lehman and subtract from it Baruch, it doesn't really equal anything. So again, since there's an order, but their differences are meaningless, we would consider this ordinal. Interval data can be ordered, and their differences are meaningful. But there is no starting point, or the 0 point that it has is just some arbitrary point. For example, if a statistician records the years in which the Baseball World Series is won by a team from the National League, the data being recorded would be the year. Now, years can be arranged in a meaningful way, and you can find the difference between them. However, there's no meaningful starting point here. See, what is year 0? Year 0 was an arbitrary point in time that people selected. The key word here is arbitrary. If you ever have an arbitrary 0 point, it usually references interval data. In this example, we're measuring body temperatures. Again, body temperatures can be ordered from hottest to coldest, and their differences can also be meaningful. Meaning, if I were to take the difference between 98.6 degrees Fahrenheit and 98.2 degrees Fahrenheit, then the difference is 0.4 degrees Fahrenheit. However, we again have no natural starting point. What is 0 degrees Fahrenheit? Well, again, it's an arbitrary point in our number scale. It's something that humans just picked. Anytime we see the word arbitrary, we know that it's interval. Lastly, we have the ratio type. And this is the same thing as interval type, except it has a natural starting point and its 0 is not arbitrary. So for example, if we take the heights of maple trees, then the heights can be ordered from largest to smallest, their differences are meaningful, and there's a natural starting point of 0 feet. The length of something can be 0 in a sense. Class times can range from 50 minutes to 100 minutes. In this example, the dataset is the length of time. Since the length of time can be ordered from longest to shortest, and their differences are meaningful, and there's a natural starting point of 0 minutes, then we say this is a ratio data type.